Seniors, welcome to your spring semester test review. Here's number 1 through 20 video. On number 1, you are to simplify each expression. If you take a look, you have a multiplication. If there's anything you can simplify or reduce, please do so at this moment. Do you see how you have a 2n squared in your numerator and 2n squared in your denominator? Those cancel out to give you 1 and 1. Okay? Now, multiply across. 3 times 1 is 3. 1 times all of that. I'm going to go ahead and factor in case I can cancel something out. Factors of n squared is n and n. Factors that multiply to give you a positive 25, but it's going to add to give you 10. N would be 5 and 5. So those are both plus 5. So now you have n plus 5 times n plus 5. Notice there is nothing for you to cancel. Now take into account you can never have a 0 in your denominator, so I'm going to set that equal to 0 and see what that is. Subtract 5, so n cannot be negative 5. So that is part of your solution. Any zeros in your denominator will result in you having an undefined. Number 2, okay, notice you have a division. You need to take the reciprocal of that. I am going to go ahead and factor these two. Factors of x squared, x, and x. Two numbers that multiply to give you negative 15 and is going to subtract to give you 2x. That would be negative 5 and positive 3. So minus 5 plus 3. Does not matter which order you put them in. Okay. Now I'm going to rewrite your numerator, x plus 1, and if it helps you put parentheses around it, please do so. Rewrite your denominator, x minus 5 times x plus 3. What's opposite of dividing? Multiplying. Take your reciprocal of the second set. 1 goes in the denominator. X plus 3 goes in your numerator. Do you see anything else that you can cancel out? These two gives you 1. Multiply across. X plus 1 times 1 is x plus 1. X minus 5 times 1 is x minus 5. And x cannot be 5. Set this equal to 0. And that's why x cannot be 5 when you solve for it. That's your final solution for number 2. Number 3, we are continuing to simplify. Okay? If you take a look, I'm going to factor out a 2 first. When you factor out your 2, you have x minus 2. This one I'm going to factor out a 2, and you have x minus 3. Okay? Combine all that you have in your denominator without repeating. First you have a 2. X minus 2. Do you have a 2? You already wrote that. Next one, x minus 3. Rewrite that one. Okay? Take a look at the first one. Cover this one up. You have a 4. You have 2 times x minus 2. What are you missing from the common denominator here? You're missing an x minus 3. So that's what I'm going to write right there. Keep your sign. Plus 3. You have 2x minus 3. What are you missing from your common denominator? The x minus 2. Bring that over. Okay? Distribute 4x minus 12 plus 3x minus 6 over 2 times x minus 2, x minus 3. Combine your like terms. 4x plus 3x is 7x. Negative 12 minus 6 is negative 18. All of that over 2 times x minus 2 times x minus 3. Is there any common denominator? I do not see any, so that will be your final solution. However, set that equal to 0, so x cannot be 2 and x cannot be 3. Don't forget your undefined. Number 4, okay? You got a 3 here. I am going to go ahead and simplify that first. Find your common denominator. I got an n minus 5. I have a 3. I like to write my numbers in front, and I have an n minus 2. Same thing. Take a look at this one. Carry your 6 over. You have an n minus 5 right there. What is missing that you have not written? These two. But I am going to go ahead and combine them. So I'm going to rewrite it as 3n minus 6. Minus 4. What is missing from these two guys? An n minus 5. Okay. Go ahead and distribute. So you have 18n minus 36 minus 4n plus 20. All of that over 3 times n minus 5 times n minus 2. Combine your like terms. So you have 14n minus negative 36 plus 20 is negative 16. All of that over 3 times n minus 5 times n minus 2. What do these two have in common that you can factor out? I can factor out a 2, so that leaves you 7n minus 8 divided by 3 times n minus 5 times n minus 2. Do you see anything you can cancel out? You cannot cancel anything out. However, you got to set each one of these equal to 0. So n cannot be 5 and n cannot be 2. So there's your final solution. Okay? Number 5. This is composition of function. Work from the inside out. Do your g first. What is g of x? G of x is equal to 2x plus 1. Okay? Next is you have your f of x. So wherever you have x, you're going to plug in this part right here. So f is, your x is now 2x plus 1. Plug it in. 2x plus 1 square minus 5. What does a square mean? That means you have two of them. So this will be 2x plus 1 times 2x plus 1 minus 5. Go ahead and multiply it out. You're going to distribute. So 2x times 2x is 4x squared. 2x times 1 is positive 2x. 1 times 2x is positive 2x. 1 times 1 is plus 1 minus 5. Combine your like terms. 4x squared plus 4x minus 4. No need to factor because that's not what you're going after. Number 6, inside out. Take care of your g first. So your g of x is equal to 8x plus 10. Next you have your f. Wherever you see an x, you're going to plug this part in. So f, your x is now 8x plus 10. Write your 4, square root, 2 times 8x plus 10 minus 1. Make sure you carry your square root over. Simplify underneath your square root. 2 times 8x is 16x. 2 times 10 is plus 20 minus 1. Simplify, so you have 4 square root of 16x plus 19. Cannot make it any smaller. That's your final answer. Number 7, continuing with your composition of function. Now we have a numerical value. Work from the inside out. You got a g. That's the first part you are going to do. Okay? So you have g. Your x is now a 4. So 4 squared minus 5 comes out to be 16 minus 5, which is 11. Then you have your f. So for your x value, you're going to plug in 11. Why? Because your g of 4 is equal to 11. So f of 11 equal 5 times 11 plus 2. 5 times 11 is 55 plus 2, which comes out to be 57. Okay. Number 8, inside out, closest to the value first. So we're going to deal with our f first. Okay. So our f of x, our x is 0. So 5 times 0 plus 2 is equal to 0 plus 2, which is 2. Now deal with your g. Right there. Okay. Your x is now a 2. So you're going to have g of 2 is equal to 2 squared minus 5, which is 4 minus 5, which is negative 1 is your final answer. Number 9, inside out. Work the g first. Take care of your g right here. Here's your g. Your x is now a 9. So g of 9 is equal to 9 squared minus 5, which is 81 minus 5, which comes out to be 76. Take care of your h, which is over here. Okay. So your x value is now 76. So h of 76 is equal to 2 square root of 76 minus 1. Okay. You need to simplify your square root of 76. I'm going to come over here and see what I know. 2. 76 divided by 2. Let me see. Get out of that. 76 divided by 2 is 38. 2 and 19. I have a pair of 2's. Okay? And 19 is left over. So now you have 2 times 2 is 4, square root of 19 minus 1. Two different terms. You cannot combine them, so those are done. Now we are going to get into logarithms. So let me refresh your memory a little bit before we start. Just keep in mind that logarithm is, you have your base, okay, times your, excuse me real quick. All right, so it is always log base b of y is equal to x. And here is a circular rotation. Exponential form is b of x is equal to y. So just keep that in mind of how you write it. By the way, this is a b and not a 6. Okay? So if you look at number 10, it says rewrite it in exponential form. So I have a log and I want to rewrite it in this form. Here is your b. Okay? Here is your x. Here's your y. So 8 to the negative 2 is equal to 164. That's all you have to do. You are just rewriting it. You're not solving. You're not doing anything like that. There's the answer for number 10. Number 11, you are to rewrite it in logarithmic form. So I'm going to bring this paper over just to refresh your memory a little bit. Okay? Keep that in mind. So here's your base. Here's your exponential, and here's your y. So we are going to rewrite it in that form. So you have log base of 19. This is all on one line. Log base 19 of a is equal to b. And there's your final answer. I just drew your line so you kind of see where it goes, how a and b are all on the same line. Okay? Keep going. Now, on number 12, we are going to evaluate. That means you are equal to something. So if you take a look at this problem, you're saying 6 to what power is equal to 216? Well, come over here, so you can say 6 to what power is equal to 216? Use your yellow sheet. Some of you have a different color. But 6 to what power is 216? 6 to the third power is 216. Okay? Number 13. Now you have a fraction. Same thing. 6 to what power is equal to 1/6? Now, keep this in mind. 1/6 is the same thing as 6 to the negative 1. Notice they have the same base. So 6 to what power is equal to 1/6? Negative 1. Okay? 14, continuing on. Same concept. So you're saying 125 to what power is equal to 5? Well, if you look on your sheet, you see how you have a base of a 5? So look at 5. Do you see a 125 right there? 5 to what power is 125? Well, this is the same thing as 5 to the third is equal to 125. So this is equal to x. Okay? So 5 to the third is to the first power. My apologies. So 5 to the third is equal to what power? So 5 to the 3 is equal to that power. Now, if you will take a look, you notice how I have an x here. See how these are like bases? So 3x is equal to 1, x is equal to 1/3. And you can check to make sure that this is 1/3, okay? So So on your calculator, you can go 125 raised to 1 divided by 3. You see how it's a 5? And all I did was, like basis cancels out, so 3x is equal to 1, because 5 to the first power. And that's how you can kind of figure it out. So your answer is 1/3. If this was a negative, you would have no real solution. All right. Now this time we are condensing. You want to write them as 1. Okay? So some of you will use your green sheet. Let's see if I can find mine. Right here. If you use this green sheet to try to help you, that would be a good idea. Okay? So keep in mind what correlates with what. Here's your condensed form. Here's your expanded form. Multiplication, addition, goes hand in hand. Division, subtraction, goes hand in hand. Okay? So, first of all, you want to get rid of all the r, which is this part right here. See that? Your exponent. So I am going to move the 5 over, and I'm going to move the 1/4 over. So now you have log base 2 of w to the 5th plus log base 2 of u to the 1/4. See that? Do you see how these are the same base? I can now combine them as 1. So log base 2, when I combine them, you see you have a plus. It correlates with the condensed form of multiplication. So here's your expand, here's your condense. So I'm going to write this as w to the 5th times u to the 1/4. Now, you see how log base is written one time? You can leave your answer like this, or you can rewrite it in this format, w to the 5th, and instead of a fraction, you could rewrite it in radical form with a root of 4. These two are the same answer. Okay. Number 16, we are now expanding. So we are going to go from this format to this format. So we want a plus and a minus because we are going to now expand. So best thing to do is put a log on every one of your numbers, okay? First off, they're all going to have the same log. Otherwise, it wouldn't be in a condensed form. So log base of 7, square root of x. See how that's multiplication? Same as plus. Log base of 7, h to the 4. Look at the minus. Minus is subtraction. Log base 7, y to the 5th. Okay. Now, I'm going to rewrite that as x to the 1/2, because that's the same thing. Plus log base 7 of h to the 4th minus log base 7 of y to the 5th. And now I'm going to bring all my exponents to the front. So you have 1/2 log base 7 of x plus 4 times log base 7 of h minus 5 log base 7 of y. And there you have your solution. Now we are going to hit transformation for logs. Alrighty? If you take a look, best thing to do is use your calculator to help you. Remember the alpha window. If you have a TI-84, that is going to be your best friend to kind of help you get your 5 points. Alrighty. Now if you take a look, it always starts at 0, 1, right there. Plus 4 tells you you are going to move left. Okay? Plus 5 tells you you are going to move up. That's what that means. So, take a look at this moment, and you will kind of see what it is doing. Okay? Now, on this part, this is what's taking place. You're going from here, 0, 1, you're going to move over left 4. 1, 2, 3, 4, 5 up. 1, 2, 3, 4, 5. Ready? This kind of gives you your asymptote as well. So you're never going to cross at -5. Okay. On your calculator, go to y equal. Okay, I'm going to clear mine. I'm going to type that in. Remember, the base is not a 10, so I have to hit alpha window, log base, type in 6, okay, right click to x plus 4, right click, plus 5, and hit graph. Kind of gives you that graph. Now, I want you just to sketch. You can tell it went left 4 and 5 up, okay? You need to get me at least 5 points. So to get the 5 points, go to second table, right? Now scroll until you see that error. You guys see that error right there? Your first error. After your first error, go ahead and sketch your 5 points. So -3 and 5. Okay? Next, it is -2 and 5.38. Next part is -1 and 5.6. Keep going. There's 1, 2, 3. And then you have 0 and 5.8. And then try to get your last one, wherever your graph is back here. So that was an 8, so I'm going to go to 8 real quick. Okay? Which is 6.4. Now, as I scroll, you notice how this one, someone has a whole number here? So I'm going to go ahead and write that down right here, just to make it easier for me to graph, and you can graph your points. So you can go to -3 and 5, right here, okay? And then you can go to -2 and 5.3, so up a little bit. And then -1 and 5.6, okay, ignore this part. 0 and 5.8. Now notice 2 and 6, that's going to help me graph. And then 8 is at 6.4. So here's your graph. Just make a sketch of your graph. Add your tail right there. Okay, so there you have your graph. It's not right. All right, so there you have it. Left and up 5. Something, it's not right. Let me check. Okay, because you're never going to cross 5. That's right. Okay, there we go. So you're never going to cross 4 either. I am so sorry. Your asymptote is at -4 right here. I don't know what I was thinking. This is also your asymptote. So there's your -4. Okay? So your graph should go right here. There we go. Let me redo number 17. I just knew something wasn't right. All right, let's try this again. Number 17. You are going to go left 4, up 5. Okay? So there we go. So here you are at 1, 1. Okay? So you're going to, your asymptote is at -4. 1, 2, 3, 4. Do all your dashes. Now, go to your calculator and get your 5 points. And here's my 5 points. It is -3 and 5, -2 and 5.38, -1, 5.6, 0, 5.8. See how I kind of go up? 2 and 6, and my last one, 8 and 6.4. Okay, now plot those points. -3 and 5, right here. -2 and 5.8, up here. -1 and 5.6, right there. 0 and 5.8, 2 and at 6, 8 is at 6.4. Now connect your points and add your tail. It's approaching it, but it never crosses. And now let's give our asymptote. Okay, so this is a vertical asymptote, is at -4. Your domain will always start at -4, not including, going to infinity, and your range will always be all real numbers. Let me write that correctly. Range is all real numbers. So there you have it. Natural log, same thing, you just have a base of 10. Alrighty, so here we go. So you are going to move to the right one and down 4, okay, for number 18. So here we go. Alrighty, clear, use your calculator, type in natural log, which is down here by -4, okay, and type x minus 1 in parentheses minus 4 and hit graph. Alrighty, this kind of gives you your asymptote. It's at opposite -1, which is +1. So draw your dashes right here. Go find your points. Scroll until you see your first error. You guys see that right there? So your first point is 2 and -4. Next one is 3 and -3.3. Next one is 4 and -2.9. See if you can find a one that has a whole number anywhere. There's not one, okay? So that way we can just kind of continue. 5 and -2.6. And your last number is an 8, so try to get that 8. At 8, it is -2.05. Now graph those points. 2 and -4, 3 and -3.3, 4 and 2.9, 5 and 2.6, and 8 is 2.5. And there you have your graph. At your tail, okay, vertical asymptote is at 1. Your domain starts at 1, continues on forever, and your range is always all real numbers, how far low to how far high. There's number 19. Sorry, number 18. Here's number 19, okay? We are going to find the domain and range. So, keep this in mind as you are doing this problem, that this here, this is your stretch, this is your A. If your A is greater than 1, you are going to have a growth. If your A is between 0 and 1, you are going to have a decay. And a growth graph looks like this. See how it's going up? And a decay graph is going down. So as you can see, and it's always crossing at 0, 1, unless there's a change. All right, so on number 19, here's your asymptote at 2. That kind of tells you where it's going to be, and it's going to stretch, okay? So, if you like, you're going to go to 2, and you're going to have a horizontal asymptote. So your horizontal asymptote is at 2. This tells you it's going to be a stretch. You notice how this is less than 1, you are going to have a decay. So your graph should look something like this. So on your calculator, you can go 10, parentheses, 1 divided by 2, okay? With an exponential, right click, plus 2, and hit graph. Now, as you can see, it's approaching 2, but it never crosses 2. And if you really want to find where it crosses the the y-axis, you can go to second, calculate, and go to value. Type in 0 because your x value is 0. You see how it's at 12? So you just go to 12 right here, okay? And you kind of see how your graph will look something like this. It approaches but never cross. Now, I'm asking for the domain and range, and I just want to sketch of the graph. Your domain, far left to far right, is all real numbers. Your range, how low is it going to start? It starts at 2, it's parentheses because it's not included, all the way to positive infinity, okay? Number 20, same thing. Your asymptote, now take a look. You see how your A is greater than 1, okay? So this is going to be a growth graph. It's going to look something like this. And if you will see, here is your positive 5. You have moved up 5. So I'm going to draw my horizontal asymptote at 5. Okay? All right. Now go ahead and graph. Try to find where it crosses the x-axis. My apologies, the y-axis. So you can go to y equal, clear, 2, okay, times 2, parentheses, let me type it correctly, 2 parentheses, raised to the x power, plus 5. See how I just enter all that? And hit graph. You see how it kind of approaches, but it never crosses. Now, you can go to second table and see where your arrows are, okay? That will help you as well. As you can see how your x, there's always a value for x. So the easiest thing to do is go to second calculate and go to 1, x at 0. When x is 0, y is at 7, so it's right here. Your graph will be going up and it's going to cross at 7. And it's going to stretch by 2. All right. Domain, all real numbers. Your range starts off at 5 and goes on to infinity. Okay? So if you really wanted to trace it, you can kind of see. So it's approaching 5, but it never crosses 5. Take a look at your y. See how y keeps getting smaller, but it never crosses 5. Just keep that in mind. All right, so because that's your asymptote. All right, that's what all I have for number 1 through 20. Good luck on your semester tests. I think you guys would do great. I apologize for number 19. I hope you got it now, and as well as 17. So, I'm sorry, not 19, just 17. If you have any questions, please ask your teacher. Thanks.